Our speaker this month is Dave Nakamoto. He's spoken to us several times in the past, and he's a member of the LA Astronomical Society. And he also does a lot of volunteer work in amateur astronomy, like at the Garvey Ranch Observatory. Anyway, so I give the floor to Dave.
I've given this talk before, so but I'm going to give it with a slightly different emphasis, especially at the beginning. Once we get to the bulk of it, it'll be more or less the same. Why that title? Well, you'll find out. Now, this doesn't relate to anything that I have to say, but I think I have to say it. Way back before Isaac Newton came up with his theory of gravity, which basically united all astronomical phenomena under one roof for the first time. Comets were thought to be, for instance, by Aristotle, was thought to be atmospheric phenomena. In other words, they're in our atmosphere, but high enough up to where it doesn't interfere with this idea, the Ptolemaic universe of crystalline spheres surrounding the Earth. Because that system, if you think about it for just a few seconds, says that nothing can travel into space between the spheres. Not allowed. Because the spheres are there, you just can't see them. And that's the original definition of crystalline, which is a solid object that is clear, so that light just passes through it. And if you're not careful, you might not notice it's there. That's what crystalline spheres are. So nothing could pass through there. That was Aristotle's viewpoint. And thanks to the Ptolemaic universe and 1,500 years of that stuff, that's why they think comets, and this is Ison disintegrating before your eyes, that's what they thought it were. Then Isaac Newton came up with his theory of back like Hayaseki, 1960, mid-1960s. That was a monster comet. But once Isaac Newton came up with his theory of gravity, the question arose, well, what about the comets? You explained the moon, you explained the planets, but what about the comets? And it was Edmund Halley, that came up with the idea that, well, maybe they're traveling through space. We know there are no crystalline spheres anymore. So perhaps these things are traveling. What kind of path are they traveling on? And Halley was the one who noticed that there was one comet that seemed to keep coming back. And he made a prediction that it'll come back in a certain year. Unfortunately, Halley couldn't quite live long enough to see this prediction come true, but other people paid attention to him, saw the comet, and said, aha, we've got a comet that's a member of the solar system. A weird member of the solar system, but it's a member of the solar system. And so that's why Halley is designated as P1. By the that's something else that I didn't get to the previous time I gave this talk. The P stands for periodic. The 1 stands for the first periodic comet ever discovered, and it belongs to Halley. Now it turns out that periodic comet number 2, that's West, and yes, I didn't see it myself, but people said that, yeah, you saw this phenomenon in the tail. Unfortunately, you couldn't see it for very long because West came and went so fast, it was ridiculous. But the second periodic comet was by a guy named Encke. And if you think that name is familiar, it should be. It's the comet that bears his name. Ironically, Halley's is one of the longer period comets of 76 years or something like that to make one loop around the sun. Encke's comet takes 3.3 years. It's one of the faster ones that we can see. We could see Comet Halley as amateur astronomers, and we could see Encke's comet. But Encke's comet is one of the shorter ones. So every now and then it comes around and it gives a favorable display out there. I think I'm doing this right. What's happening here? Not advancing.
Oh, you have some blank?
Yeah, but I'm not seeing even that right now. I'm not sure. Why it's
Go
not
go
advancing.
go forward twice.
I just clicked why.
Huh.
What's going on?
Here, let me go
Look at
forward. Huh.
By the way, this is one of the reasons why everybody was wondering what to make out of comets, because the once telescopes came into the fore, we could observe many comets that we couldn't observe before. Encke's especially is not a naked eye comet. Halley's is, but Encke is not. Well, it's one of those pointing at my head.
You're actually making it go here, but it's not.
Why isn't that advancing up there?
Yeah, it's not advancing up there. Okay, let's
That's weird. Try yourself. Click on the next slide. It's blank. It's that one right there.
Yeah.
Oops. And it's not advancing. Huh? Something.
Yeah, it's the cable commitment.
Yeah, we can't advance it.
No, this is the only cable to that, and it is getting this picture.
Number two tonight. Number one is I used to be able to bring my laptop, which is right over there, just plug it in and away we went. Guess what? Doesn't work. I mean, I can do it on my screen, but I can't make that happen. I can't display up there. So obviously one of the IT guys came in here and messed the whole thing up. Yes, I'm blaming the IT guy. I myself am not an IT guy. I'm a software programmer and systems level engineer. I can blame them all I want. There it goes. Okay. 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 Now let's see what's going on.
Oh, huh.
Okay, now we come to this gentleman here. He's very interesting. Amateur astronomer, but his profession is officer in the Austrian army. He was stationed someplace, and by this time we had telescopes. This is about the early 1800s. So we had telescopes. He was cruising around up there, and then he noticed a comet-like object. A lot of reporting back then. Remember, I said early 1800s. So there were no phones, there was no electricity. It's snail mail or no mail, and so the word got around fairly slowly, if it got around at all. But he happened to notice a comet, and he was good enough at math that he was able to derive the orbit, and he found out this was another comet that had a closed orbit around the sun, about 6.7, 6.8 years. And so guess what? His comet, and his name is Biela, his comet is P3, the third periodic discovery. Now, Encke is still with us, not the man, but the comet. And of course, Halley's is still with us. But tonight's story will be about this comet. Toward that.
Toward the.
Oh, yeah, I'm trying to point to the projector.
Well, actually, you have to point it to the, but you're making it change.
Yeah.
It's changing. Yeah, I don't know why.
Yeah, that pointed towards that flashy light thing,
What flashy light thing?
right by the computer.
His computer?
Yeah.
Yeah. See, it's when you do that, it's changing on mine.
Yeah, but why is it not changing up there?
Yeah, that's really strange.
Okay, I'll just keep rotating it around until it change. Yeah. Great. Curse the IT guy.
Be the battery in your trigger?
Could be.
I don't think so. It's a fairly new battery, and like I say, it's when he clicks it, it changes here on my screen.
So your computer is not talking. Yeah, right.
Gee.
Oh.
Well, oh, brother. Okay.
It's not bad contact.
Yeah, I read the battery's position, it could have been that. Okay, that's what he saw. Most, just like Enki is not visible except through telescopes, Biela's comet is also not visible except through telescopes. Farthest it ever gets is about 8th mag, which is considering the scope technology at the time, early 1800s, that's getting pretty dim. Let's try to check out of it. But he detected it. They found out it was periodic. And so they waited for its next return. And here we go. There we go. Now, 6.8 is one of those interesting numbers where every other time the comet comes around to our neighborhood, it's in a favorable position to observe, either in the morning or the evening. The problem with that is you miss every other time. So, but every time they were able to observe it, they were able to snag it away. And the comet continued in this orbit. It turned out that there were previous observations, but nobody made the connection. So that once they had an orbit and they could predict where it was, they went back in the old record and say, well, that guy saw it. Well, that guy saw it over there. So it was periodic. Okay. Okay. I know what's happening now. Okay, I'll just stay on the slide. On one of its returns, though, it turned out the second to last one. Now we're going to get to why the comet would die. It is split in two. This guy is the main comet, which will appear later on. And this is the part that we think didn't die, maybe. This part split off. And it was a very weird phenomenon for the astronomers to observe at the time because they alternated in brightness. First, the bigger fragment would brighten up, and then it would fade, and then the smaller fragment would brighten up, alternating back and forth. Something else also happened, which was very hard to explain at the time. And it wasn't until a couple of decades ago that the real explanation for it showed up. But what happened was, and I remember I saw a drawing of this thing, and I can't find it anywhere on the internet. Boy, did I look. But there was a bridge of material linking the two parts, which everybody just gasped at, and they wondered what the heck is going on here. Well, okay, see, that's a better drawing of it. And that's where the explanation. That is Shoemaker-Levy. Before it decided that each one of its little fragments was going to hit Jupiter, which I saw along with Curtis Byram from the same locale. But what we think now happened with Biela and why that linking bridge, a bunch of these guys, which with the telescopes at the time, they couldn't separate out. So they saw a continuous line of material between these guys. This is a Shoemaker-Levy. You can already tell here it's uneven. They're too close together right there, and an additional fragment that's very faint between those and the next one over. So you could tell this is a chaotic event. Somehow the perception back in the 1840s, I believe, was that a continuous line of material. And then it disappeared, which everybody expected, because it's going out where Jupiter is and coming back. By the way, if you see any comet and you see that the orbital period begins with 6 years, some fraction, that's a Jupiter family comet. That number indicates that when the comet gets out to its furthest point in its orbit, guess whose orbit is right there with it? Jupiter. Which means that if it's not tilted significantly to the plane of the ecliptic, guess what happens? Jupiter is going to affect it one of these times it comes around. It may not affect it this time, the next time, or next time, but it's gonna affect it. As far as we can tell, that didn't happen to Biela. But Biela had other problems. So the next time around, they were wondering what's gonna happen to the two fragments, because first off, they were slowly separating at a very slow rate, based upon the records we have at the time and the distance that Biela was at. We figured they were separating at maybe about 1 meter per hour or something like that. I mean, it's a really, whatever happened to it was a really slow separation. The other thing that we think now these days happen is that the smaller fragment was mainly ice. In other words, a big chunk of ice just caved off the main fragment. So the main fragment still was composed of dirt, rocks, and ice, whereas the secondary fragment was just ice, which is going to evaporate in a big fat hurry. And sure enough, that's what happened. They did see the second fragment. The only problem was it took them several weeks before they saw it. Not because of any of its intrinsic faintness, but because it had separated from the main fragment. Remember, 1 kilometer per hour, 1 meter per hour over 6.8 years. That's a lot of distance. So that's what they think. That's what they observed happening. And I'm not sure what the next slide is. Now, the next time around, they looked for it, even though it was unfavorable, didn't see anything. Next time around, they looked for it again, unfavorable, didn't see anything. And so people thought, okay, both fragments died or are in orbit that we can't observe them. But Brian Marsden used computers to calculate the orbits of some of these comets, and he found out that no, not even Jupiter affected Comet Biela. So if it's there, it's in the same orbit. But we'll get to that in a little while. But what happened was spectacular, and here I really need to look at my notes because the numbers here are just startling. So let me just take a look real
Hang
quick.
on. Here, let me get down to the same slide.
Okay, that's the first one there.
There.
Okay, down there. Okay, that's the one I wanted. Okay. Let me stay there. Okay, that last number is what I wanted. On the night that a lot of astronomers were looking for Biela, a heck of a meteor storm occurred. Now, you may have heard of showers. If you heard of a strong shower, you make it up to 100 to maybe 150 or so per hour. I actually observed that with the Perseids back in the 70s. And we actually did a count from north of Ojai where we counted anywhere between 145 and 150, depending upon what the count was per hour. And that was spectacular. But when this thing occurred, during a 7-hour period from some parts of Europe, they counted 160,000 per hour, which translates to a rate of 380 meters per second. This was a legitimate storm. I mean, this basically would flatten anybody. And it was observed for a 7-hour period. And many observers in Europe observed it. Now, why this relates to Biela is very interesting. It turns out that on that night, the Earth passed through Biela's orbit. And so the thinking, but unfortunately, when they did the calculations again, they found out, no, Biela was not in that part of its orbit when the Earth hit it. So now they realize that, oh, this is the stuff that came off the comet. And now we're getting hit with it, like we wouldn't believe. But that rate to me is incredible. Remember, 140 to 160 per hour basically means you've got an average of a couple per minute, something like that. This was a much higher rate. 380 per second is like insane. It's absolutely insane. And so far as I know, it has not been matched really by anything certainly in the 1900s and into this century so far. Now, we can't tell because the distribution of material in a comet's orbit that came off the comet is not really accurately known. We know that near where the comet was, or whatever, it's going to be densest, and it's going to be least dense on the other side of the orbit from where the comet is. But this is absolutely nuts. And yes, more than one person and more than one locale saw a brilliant display. Unfortunately, it's not happened again. As a matter of fact, when we passed through Biela's orbit on successive years, the count really took a nosedive. Until now these days, I think this particular shower is maybe 10 per hour if you're lucky. That's the peak. So most of the material has moved on, or maybe we collided with it, and they're all gone. So then that's when you think that interest in Biela would subside. But this character, who happened to be Brian Marsden, he used I'm not sure if he used that computer. That looks like an IBM to me. But he used computers to figure out the orbits of comets that were lost, including Biela. He tackled Biela under these assumptions. The Theta fragment, he figured, no, that thing evaporated. That was probably he's the guy who came up with the idea. It's a chunk of ice, huge chunk of ice, it evaporated. But what about the brighter fragment? He thought that, well, if it still survives, it's probably an asteroid, which might explain why we never saw Biela ever again. We just never did. So he figured out, well, if that thing was an asteroid, and assuming that it turned into an asteroid the last time anybody ever saw it, where is it now? And so he put out the broadcast that, okay, I predict if you're going to see Biela at all, you're going to need deep photographs. It definitely is not a comet anymore, but it's more or less in the same orbit that it was. It just shifted a little bit, thanks to, as we know now, rocket effects from when the comet spews out material. It acts like a rocket. And that happens with all comets. That's why comets drift somewhat in their orbits, totally independently of coming close to any planet. There's a little bit of a drift, a little bit of shift in the orbit. And that's what has to be accounted for. So he accounted for that, and he said, well, here we go. Let's look for it. I'm pretty sure none of you recognize this character. I'll give him away in a minute. So several people tried to look for this fragment. And they used various instruments. Now, this character used a Schmidt camera and photographed the area where he thought the comet was. And he saw a comet. But it was a little out of position. And further observation showed that the comet he saw was not Biela. So since it didn't match any other cometary orbit, they named it. This is the good thing about discovering comets. Guess what? That's the only way you're going to get your name in the astronomy ledgers. Because by tradition, usually the person, and I'll explain that in a second, the person that discovers the comet, his name is emblazoned on it forever. Which is why we have, Enki and Biela. We really shouldn't have Halley, because guess what? He never saw his comet. But he was the first one to predict that thing is going to come back in this year. So keep a watch out for it. And it's going to have this orbit. And everything came out the way he wanted to. And that's why we call it Halley's Comet. Not because he discovered a darn thing, but because he figured out, okay, this thing actually is a member of our solar system. So it's just like a planet, except a little different. This is Comet. Ludwig, I think his name is Ludwig Comet.
Lubosh.
Huh?
Lubosh.
Lubosh, thank you. So Unfortunately, as some of us who, like me, who lived through that area are fond to recall, this comet did not perform. And it wasn't, for the purposes of this story, it wasn't Biela. But once again, Biela was thought to have been dead. And this guy runs across something, turns out to not be Biela, but it was close to where it should have been, Biela was. But it was an independent comet, and we named it after him. So Biela keeps coming back. Now, I'm not sure if there's anything left to the slides.
There you go.
Oh. Okay. It turns out that there are a couple of suspicious objects discovered in the last 2 or 3 decades that raise the question of, is Biela actually dead or not? One of this, I think this is Mercos, one of the ones that he discovered. It turns out to have a very similar orbit to Biela, but unfortunately, when they crunch the numbers through the computer, it's just far enough off to where they say, no, this is not Biela either. Let me take a look to see how far I have to go before I run out of slides.
I think
That may be the end.
that's it.
That's it. Yeah. There was another comet, unfortunately, that was intrinsically faint, which is a fancy way of saying your chances of seeing it or even photographing it are somewhere between slim and none. But it seems to resemble Biela, except that the one of its orbital parameters, which is called the argument of perihelion. And what that is if you imagine the comet's orbit, the point where it's closest to the sun is perihelion. Peri meaning close to, and helion is the sun. It's close to it, but it's rotated with respect to where Biela's orbit should be. So even though everything else about the darn orbit looks like Biela, it's not about to be Biela. But it is a comet, doesn't put out much. But so the search for Biela can continue, but I doubt that they're going to see anything. I do think that that meteor shower was the last hippopotamus, and that Biela is officially dead, but it keeps coming back. So who in the heck knows? And okay, any questions?
Well, let's give David a good hand here. Any questions?
Anything at all, either generally on comets, doesn't have to be on Biela.
I have one for you.
Tim, you have a smile on your face.
Oh, didn't know.
What were you gonna
I
add?
will actually going to suggest something for the PVAA.
Okay,
You should have a Comet Biela recovery party and figure out when Comet Biela would normally be visible and go looking for it, you
I
know?
think that
Because
would
if
be
you
good.
can find it, you can headline, you
That's
become famous.
yeah.
We'll name it after you, Tim.
So I got a name.
There would be an asterisk.
Well,
Yep.
I have a question for you, Dave. Are there any comets right now that we know about that may turn out to be fairly good sites coming up in the next year?
Sort of. There's an interesting site. If you want me to give it to you, just let me know. But I've been using it for years and years now. It's by a Japanese astronomer, amateur, and he keeps track of all the visible comets. Now, visible is kind of a loaded term because he lists visible comets down to 13th mag, which let me tell you my own experience real briefly. Anytime you see a published magnitude about a comet, add at least 2 to that number, and that's what you're looking for. You're looking for an object that faint, because back in late 2017, early 2018, I decided, well, let's see if some of these 8th to 10th mag comets are even visible from Garvey Ranch. If they weren't 8th mag, they weren't visible. And compared to the stars in the field, that comet was 10th mag, if it was 10th mag. And that's why I say, if they say it's 8th mag, add 2, it's 10th mag. That's what you're looking at. Because, and then I couldn't figure it out until one of my buddies who doesn't discover comets, he monitors them visually. And he says, oh, I forgot to tell you, that's that, what do they call that? That's where you take an extended object. An extended object simply means it ain't a star. That's all that means, really. It ain't a star, it's got a glow around it. You take all of that glow and condense it into a point, and that's the magnitude you publish. Well, that
Integrated, right?
integrated magnitude, thank you. I couldn't think of it off the top of my head. The problem with that is that it doesn't tell you how intrinsically bright or not the object really is. You can reverse the process by taking the integrated magnitude, and if you know the rough size of the object, you just simply divide that number into the area, and that gives you the magnitude per area, which actually is the visual and photographic too. And when I did that for several of these comets, it's like, yeah, these 8th mag comets are 10th mag or 11th mag.
It's really the surface brightness you want to know. That's what
Yeah.
he's talking about.
Yeah.
Nobody
Area
publishes that?
Huh?
Nobody publishes the surface brightness?
Not the comet.
Oh, boy, what a bunch of losers.
Well, I mean, deep sky objects, they often they publish the integrated magnitude, and that's a bunch of hooey right there because, well, as we all know, one of the problems with galaxies is that the first thing, and probably the only thing you're going to see with a galaxy, unless it's exceptionally bright, is the core, because it's fairly stellar and it's not very extended. So you're going to see the core. Whether you see anything else of the galaxies, rots a ruck, because typically, like spiral arms, are anywhere between 3 magnitudes fainter to worse than that. Which is why at Gary Ranch we don't waste time with galaxies, because it's like, even photographically, they're really, really, really tough to pull anything out of that urban glow. They're really, really bad. Insofar as comets are concerned, I think it was Comet Lemon with 2 M's. It's not like a fruit. Maybe up to 8th mag sometime in November and December. Unfortunately, in November, if I remember correctly, it's like 5 degrees above the horizon when the sun sets, and in December, it's like 15 degrees above the horizon when the sun sets. So you're really fighting that twilight glow. See, and that's part of the problem. See, ideally, but it never happens, except for once in my case, you get a very bright comet that's high in the sky. That was Comet Holmes during outburst. I remember I took my 10-inch Dobsonian, which I don't think it was the one before the one you owned, Jeff. I took it out there, set it up, and casually, and I'm observing from the driveway of my townhouse. And I was getting ready to turn off the lights. I just happened to look up, and there it was, right there. You didn't need a telescope to see it. All you need to do was look up, because it was fairly close to the Earth. It had gone into outburst. Comets do that. That's part of the unpredictability. For whatever reason, something happens to the comet, and this silly little thing might brighten by 1,000,000 times. But that effect only lasts for maybe a week if you're lucky. Probably only a few nights if you're more usual. But it went into outburst, and it was at opposition. In other words, it was in the opposite section of the sky from where the sun was. So it was available all night. Absolutely amazing. That was the last super bright comet that I've seen. Unfortunately, by the time I got the word out, it already faded.
I got another question for you, David. I recently saw where I guess they're now saying that Oumuamua was a comet, and which I guess they now claim all 3 interstellar objects that have been found are now classified as comets. Is that any ways surprising to you at all?
Not really if
No.
they came from interstellar space, because remember, especially water ice is very prevalent. And you can just prove that mathematically almost. First off, all you're going to get from hydrogen, if all you have is hydrogen, is 2 hydrogen atoms doing this. Very boring. Nothing else happens. Helium won't combine with anybody, so you can kiss him and toss him out. Once you start going down the list, you have to get the carbon and oxygen before you get the next really prevalent elements that are worth something. In other words, worth something meaning that they can actually chemically combine with more than one bond. And it turns out that one of those prevalent is oxygen. Well, if you have any oxygen and your hydrogen is everywhere, it's all over the place. So the question asked is, what is the most common compound in the universe? And guess what the answer is? Water. So you're gonna find H2O if you find any compounds anywhere, and that's generally what you find. Now, the next most common is, of course, carbon dioxide, but it melts at a it evaporates at a much lower temperature. So generally, with a comet, as it's coming in, you're going to see it start outgassing. That's probably carbon dioxide. There are other compounds in there, but predominantly it's carbon dioxide. When that is finally used up, you better hope and pray that it had water ice in there too. That takes over from about the orbit of Mars inward. But if it didn't have a lot of water ice for whatever reason, guess what happens? Comet fizzes out. And that's happened. We've seen that happen. There was a comet called Westfall, and it was predicted to become naked eye magnitude easily because the light curve was shooting up like a rocket. Unfortunately, long before it ever reached naked eye magnitude, the curve went this way. Until at perihelion, we had difficulty photographing it. Even the professionals did, and it's been lost. It's been lost. So comets are, unfortunately, comets are very unpredictable. So the word I give to everybody is, if you do hear that a comet is visible in the evening sky, for crying out loud, to set up in your backyard and see if you could get a look at it, because it may not be visible for long. Because it may not be in the sun's vicinity long enough. It may be made of the wrong ices. I mean, everything is against you, or it could completely evaporate. I don't think Hyakutake, which was 1994, memory serves, I don't think it completely evaporated. There wasn't much left to begin with there. The thing was less than a mile in diameter. So by the time it cruised by us, and I saw it in the nighttime sky, by the time it cruised by us, and the southern observers are getting ready for their show, the comet was gone. Basically, it was gone. So you can't tell. And that's one of the vexing things about comets. You can't tell what they're gonna happen. A lot of things that we thought were asteroids are now comets, and a lot of comets are now asteroids. So it's like, but right now, our only hope, there may be a sixth mad comet sometime early next year, February or March. I'm still on the watch for that thing. It looks like it'll be fairly favorable. I think its altitude is like 20 degrees or 30 degrees above the horizon. And it should be in the evening time sky. Because the only thing we know for certain is their orbits. That's the only thing, unless the silly little thing says, I'm gonna kiss Jupiter. I'm gonna get really close to Jupiter. After that, it's like, all right, more rounds of observations, because we got to figure out what the silly thing, how its orbit was altered by being so close to, and that's happened before. When a comet approaches close, I think Lexo was the one who approached close to Earth and got tossed into a completely different orbit, where we're not going to see it for 400 years. It used to be a fairly short period. It used to be like 10 years. And now you have to add a zero to that.
Yeah.
And then tons of them have been affected by Jupiter, which makes sense because Jupiter is the biggest, baddest, other than the sun, biggest, baddest gravitational source in the entire solar system. So if the comet and several comets have done that and totally altered their orbits. That's a topic in and of itself that I'm fascinated by. But it's like, yep, when you're dealing with a little schmutz of ice, and you're dealing with a big that gravitational source, anything can happen after that. And that's what part of the problems with comets is that we do know their orbits like right now. But if they get close to any planet, that's like, it's almost like the kiss of death. You don't know what's gonna happen after that. So,
Okay, well, thank you
okay.
very much,
Yeah,
David.
go
That's
for it.
really interesting.
Thank you. Whose control is this? Oh,
Okay.
okay, let me shut down my computer.